and thank you to our new parents who are here for our parent night. Tonight we are going to go over Unit 4. There are 6 total units for Grade 4 math, so you can expect another math night for Unit 5 and for Unit 6. When we get close or when we're starting that unit, that's when we'll send that information out. There's really no way of telling. Unit 4 is a very long unit. Yeah, it's long. This should take us probably through March. Yeah, fractions are a huge part of the PARCC assessment, so they've made it a huge part of 4th grade math. You guys all have your materials in front of you. Obviously, there's plenty extra.
Monica, Daniel's mom was coming, but she got held up at work.
Go ahead, you can
So I
take
told
a copy for her.
For 2.
Sure. We have plenty extra, so that's no problem at all. So our objectives for tonight, we are going to review topics in the Unit 4 curriculum, and we are going to examine fractions using a Common Core lens.
So these are the topics that are covered in Unit 4, and you guys have them, and these are the ones that we're going to go through tonight.
At the bottom in red, you'll notice that the additional advanced topics, these are students that will be in the advanced class who will only be doing those topics. So they'll be using simplest form, multiplying fractions by fractions, adding and subtracting, unlike fractions and mixed numbers, as well as all of these other topics.
In the same amount of time.
Yes. Yes. So it's lots of fun. Lots and lots of fun.
Alright, so the first topic we're going to talk about is equivalent fractions, and we teach equivalent fractions using area models, number lines, and a form of 1. So these are our area models, where we teach them to draw pictures. So if we have 4, 6, then the equivalent fraction to that, we could shade to make equal. 8 would be equals.
Notice that the size of the whole is the same.
Right, because like
So-
when Annie came home the first night with it, there was something where she had to like shade this, and then she shaded this one like different, and it was wreaking havoc with like what she was trying to do.
Exactly, the
So-
size of the whole has to be the same
Okay.
if you're comparing fractions, basically like this. If you draw one gigantic fractional model and one small one, we talked about Cheesy's Pizza versus a Lunchable pizza. If I wanted to split half of a large Cheesy's Pizza with you versus half of a Lunchable, the fraction 1/2 is the same, but are you getting more pizza with the Cheesy's Pizza or the Lunchable? So we've had conversations like that. A lot of talk with fractions will be about food. It makes it more engaging and real life.
Alright. With the drawing and the writing of fractions, we talked today about writing neatly and making sure the kids are taking their time so that it's easy to see and it doesn't get them easily confused when they're drawing their pictures. Alright, so then for 5/20ths, now the kids could probably draw this or shade this in a bunch of different ways. They could do it like that, but then it's more difficult for them to see what that
That's
looks like
what we-
over here. So it's a lot of visualizing before they start to draw. So how could we make shade here to make it look like one of these? And then hopefully they would be able to see that it would be the same like that.
That's where we have.
Yeah. It's a lot of visualizing for models. Alright, and then down at the bottom, we have 2 holes that are the same, but we need to draw the lines in there. And again, this is where the kids would, you know, if they're not taking their time, they're gonna make their spaces, their parts, different sizes. And then they're not equally spaced. So you would draw your fifths. And then they could shade their 2. And then on this side, hopefully they would be able to see that you could just draw
Cut
a
it in
line
half.
right down the middle. To make the tenths.
We've had a lot of conversations like this over the last couple of days.
With the kid?
Now between each other.
I was gonna say, mine was right too. Well, I was we were working on STEM fair, so I was with Danny,
Yes,
and he was doing this.
yes.
And he tried to draw something similar to this, and he made like the 10 one like crazy looking. I was like, no, draw just like the five.
Yes,
And now how can you make that 10?
They'll
and then
take
he
that
saw
and
us
they'll
make
draw
it
the
in half.
lines.
Exactly.
down the middle.
Right, and but it kind of worked.
It's hard because we jumped right into equivalent fractions this year, and in the past, we've just done, what is a fraction? What's a numerator? What's a denominator? What are fractions in terms of real life things? Are fractions just pictures with shapes? No, they're numbers. So we had to jump right in and kind of combine all of those lessons. They're expecting the kids from 3rd grade to pick up here, which is a pretty tough place to pick up from,
We
which is what
learned
we
this
thought.
year.
We've been moving very slowly. We've been moving very slowly.
I was gonna say, I don't recall doing this.
I believe we're on our 7th day of the unit tomorrow, and I'm still on lesson 2. So
More about
keep in mind, we're going slow. We want to make sure all of the kids are feeling good about everything before we really move on. Next slide.
This is you. Is it? Okay.
All right, so we can also use number lines for equivalent fractions, and we can use number lines to show that the size of the whole is the same, but the number line can be partitioned differently. That word partition is a big word with Common Core math. It just means breaking it up into equal parts. So partitioning is just breaking it apart. Here, I always tell the kids that they have to count the number of equal parts between 0 and 1. I start with 0, and then I draw little bumps. 1, 2, 3, 4, 5 equal parts. If there's 5 equal parts, they're called fifths. So, if this is 0, this would be 1/5. The next one would be, what do you think? 2/5. And this is a pretty easy task for the kids. And then they can see that 1 whole is 5/5. And I could even say, what if you wanted to shade it? Some of them shade in this section and then put a point there if I said shade until 2/5. Now, if I use the same size number line below, meaning the whole is the same size, do you see that I've just cut each fifth in half? So now how many equal parts do I have? Start at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 equal parts are called tenths. So then this would be 0 tenths, 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, and so on. And every time we hit a fraction that's equivalent to 1/2, we mention it. So I'll say, hey, what's 5/10 equal to? And they should all be able to tell me 1/2 and just say, why? 5 is half of 10. And then we list off a couple of fractions. What are some other fractions that are equivalent to 1/2? It just helps to build their number sense. There are an infinite number of fractions that are equal to 1/2. There's an infinite number of numbers between 0 and 1. And that to them is mind-blowing. The bars.
Yeah.
We're going to do that next. We're doing that next. So, looking at this, I can see that 1/5 shares a spot on the number line with 2 tenths. So I know that they're equivalent. Same thing here with 2/5 and 4 tenths. They share a spot on the number line. Same thing with 3/5 and 6 tenths. Same thing with 4/5 and 8 tenths. They share a spot, so they are equal. Are there any questions on that? We're getting to this, we haven't gotten here yet. This is the next lesson. Good? And then finally, we get to probably what you know for multiplying and dividing to find an equivalent fraction. I'm sure if I said to you, here's the fraction 2/4, you would say, well, I can just multiply it by 2, and I can say 4/8, correct? But are you really multiplying by 2? No. If you were multiplying by 2, you totally change the value of 2/4. Anytime you multiply by the number 1, you get the same number, don't you? What's 5 times 1? 5. What's 10 times 1? What's 1 million times 1? 1 million. That's the identity property of multiplication. So, Common Core way is to tie it in and say, We're always multiplying by 1, we're never changing the value. So I could say 2/4 and then multiply it by a form of 1. A fractional form of 1 just means you have the same amount of parts shaded in as you would altogether. So here, I have 2/4. I have how many equal parts here? 1, 2, 3, 4. 1, 2, 3, 4, 5. 4 times 5 is 20. So I say to myself, 4 times what would give me 20? That would be 5. And if I'm going to multiply by 1 whole, how many fifths do I need? 5 fifths. The only reason we do it like this now is so that students understand that 1/2 times 1 is 1/2. No matter which way you divide it up, you're still getting half of the birthday cake. You can slice it up as many different ways as you want, you're still getting half. And that's what we're doing. So let's take a look at this one. Can someone tell me what fraction is represented here? 10 14ths? 10 14ths. There's 10 parts shaded, 14 parts altogether. And now I'm going to, how many equal parts?
7.
I'm going to 7 equal parts. I don't know what my numerator would be. I say to myself, 14 divided by what would give me 7? It would be 2. And I know I need to divide by a form of 1. So I'm going to divide by 2/2. So then 10 divided by 2 is 5. It's literally the exact same thing. It just adds in that fractional form of 1 piece. Any questions so far? So why don't you guys go ahead and try these 4? But there's one special one on that paper that you might want to take a look at. Would this number be for the numerator? 6. So therefore I should have 6 sixths because that's 1 whole. So then 2 times 6 would give me 12, which means that 1/2 is equal to 6/12. Over here, 8/10 divided by what form of 1 would give me how many fifths? I look down here, 10 divided by what gives me 5? We got 2, which means that I need to divide by 2/2. 8 divided by 2 is 4, meaning 8/10 is equivalent to 4/5. Over here, 6/8, what am I doing here, multiplying or dividing? Dividing. So I'm dividing by a form of 1. You don't have to do this, and you don't have to go through all of that. How are you? But if you want to, you can. Eventually, they're going to get to the point where they're just going to write in divide by 2/2. But they will never just write divide by 2, divide by 2. They have to write it as a fractional form of 1, no matter what. So, 6 divided by 2 is 3, 8 divided by 2 is 4, which means that 6/8 is equivalent to 3/4. And over here, could you divide by a form of 1? You can't. 10 divided by what would give you 6? What whole number would give you 6? Nothing. So a lot of times the kids would just stop here and say, I don't know what to do now. Instead of looking at it going across, then we say to them, look at the whole fraction. What do you know about 5/10? Same as 1/2. Therefore, what's half of 6? 3. And there is no form of 1. Okay? Everybody with me?
Yep.
All right, let's get to topic 2. Some of them will be faster than others, we promise.
Alright, so again, we have the number line. And Miss A likes the loops. I like to draw a rectangle. So I teach our friends to draw the rectangle since the first time they see fractions is typically with a shape. And we would just connect our lines. And then they can see how many equal parts there are. Now, the only problem that I have noticed so far with this is that they want to put their fraction in here instead of on the line. So they would want to do 1/5 instead of writing 1/5 right on the line. So that's the problem that I've seen so far, and that just comes from careless mistakes.
And if you had just a bar model, that centerpiece would be worth 1/5. You're saying that that whole section is worth that, but on a number line, it's very particular.
So we expose them to the number line from 0 to 1 whole. And then we take it in where your number line extends past 1 whole. And my class did this today, and we're going to continue with this tomorrow. So when we're looking at this, we want to just go from 0 to 1 to begin with, to see how many equal parts there are. We have 1, 2, 3. So I know 1 whole is the same as 3/3. So then I can easily number my parts. And then continuing on. My friends did a really nice job today of being able to write as improper fractions, and then as being able to write as mixed numbers.
And to know that those are equivalent is huge.
One of the things I did see today was that some friends just looked from 0 to 2 and thought that was the whole. So they would say, oh, well, there's 1, 2, 3, 4, 5, 6 parts. But they have to look very carefully at where their numbers are. They can go from 0 to 1, or some of our number lines don't start at 0. They might go from 1 to 2 to 3. So just knowing to look in between the whole numbers is going to give them their parts.
A lot of the times I tell my kids connect underneath and then write 1 whole. This helps them mark it out, show their work.
It's huge to have them understand how to manipulate the drawings on their paper so that they become familiar with that on their classwork, on their homework, and on their tests, so that we can really see their thinking, and it helps them keep track of every little step that they make. So there are 3 equal parts in 1 whole, and we call them thirds. All right, renaming mixed numbers and improper fractions. Again, we want them to see that they are equivalent, they are one and the same. So our friends saw some of this today. A mixed number is made up of a whole number and a fraction. A fraction is part of a whole number. And then an improper fraction is where your numerator is greater than your denominator. So down here we have a visual of that. We have 2 wholes shaded and then 2/3 shaded. Or if you were to count them all, we would have 1, 2, 3, 4, 5, 6, 7, 8 thirds shaded, because each whole is broken into 3 parts. Are there any questions with impropers and mixed numbers yet?
Are your memories being refreshed back to elementary school? All this stuff?
All cobwebs haven't cleared out yet.
All right, so here we have a visual to show us a mixed number and an improper fraction. If we look at our mixed number, how many whole circles do we have shaded in? We have 2. And then how much of our fraction do we have shaded? 5/6. So you have 2 and 5/6, which is the same as 17/6.
Something that's really important to remember when they're counting like this is not that these are wholes, that you're just counting these parts that we call sixths. So even today, when I was going through this with them, I was labeling it differently. I labeled 1/6, 1/6, 1/6, 1/6 to show them that each whole has 6/6. Then this whole has 6/6 also. Some of them might then say, oh, 6, 12, and then keep moving. This is where multiplication comes back to haunt them. Really and truly, in the fractions unit.
You mean not knowing?
Yes. Not knowing your facts, it will always come back. Always.
All right, so we can also, instead of drawing pictures all the time, because when you have 7 and 4/10 of something, you're gonna get tired of drawing 7 pictures and, this gets to be a lot. So we teach them that you need to rename the whole based on the number of equal parts. So here we have 4 in a whole. And if we have 3 wholes, that means we have 4 fourths, 4 fourths, 4 fourths. And we have 1/4 left of the next piece. So if we were to add all of that together, 4 plus 4 plus 4 plus 1, 13 fourths.
Does anybody remember the way that you learned it in school, looking at these numbers in a circular pattern?
I would multiply like 4 times.
You would do 3 times 4, and then you would add the 1, right? But does that teach you anything?
Guess it taught me that it was 13 fourths.
It taught you it was
And I
13
still
fourths.
know it today.
And I still know it too. And eventually we are gonna get to that point where we might say to them, this is a faster trick. Some of them, even in my advanced class this afternoon, pointed it out. They knew it already. And I just said, try to think of it this way. You can think of it that way in your head too, but we need to expose them to this because on Park, they might have something like this. They might have to break up that number into wholes in such a way. So it's a different way of thinking, but it still gets you to the same thing.
All right, do you think you guys can try 2 and 2 6, not doing it the way you learned it in school?
You can do that way to check your answer.
We just did it. Try 2 and 2 6, the way we just did it. 6 plus 6 6 would give you 2 wholes. And then you have your fraction of 2 6, or a total of 14 6. Any questions with that one?
Now, why didn't you do, okay, I see. You're just summing up 2 as 6 6 twice. I was doing 6 6 plus 6 6 plus 6 6 plus 6.
No, right, that's their two
Right.
ones.
Just do the whole number.
Okay.
Right, and then for 7 and 3/4, our whole would be 5/5. And since we have 7 wholes,
You do it 7 times.
7 times. Did you think that, Miss A?
That's 6.
That's
4, 5,
6.
And they should be able to skip count by 5 very easily.
Yep.
38.
And if you checked it with your thinking, 7 times 5 is 35, plus 3 is 38, you get the same answer. All right?
And now we like, yes,
We came in a little late.
Okay.
So this whole class is, tonight is on the fraction.
yes,
Yeah,
unit
that's good.
4, that's what we're in now for math.
Okay, because that's not what I was confused about. I was confused about the little boxes that they were doing with division.
Oh,
The
that,
area
we
model?
had a math
Yes.
night
Yeah.
in November for that.
And, yeah, and it just kept going on, and I was so thankful to God when it got to fractions, something I recognized.
Yeah,
Well-
the division is the biggest change, I would say, for us.
So they'll still go back to that at some point?
Division, I mean, they'll be required to do
With-
that
with
on
the
the card,
next
for
year.
sure.
Boxes?
Yes. Your child, if they are ever confused, they should be bringing home their math notebook. Their math notebook has study sheets of all kinds in here. And we break it up by unit, I'm holding it upside down. We break it up by unit here. And you have, no I didn't, she just folded it backwards. And we just have little study sheets in here that will help with homework. Things that they glue in.
Absolutely, they're encouraged to bring it home.
Encouraged to bring it
It
home.
should be going back and forth. Home and school, home and
So
school. home
you'll
and school.
notice that this right here was glued in today by my class. They'd have a top example, then they did it with me, then they glued it in. So not only did they watch me do it, they then did it themselves, and then we talked about it.
There's
So we
also
have an example.
a video link of our division math night on our Twitter page
Oh,
that
okay.
goes through everything they did through division. I videotaped it like I'm doing now.
Okay.
So that can also help you.
Okay.
If you don't do Twitter, do you do like Facebook or something?
Mr. Jasper does put it on the Facebook, and I also have the link to the actual video that I can have them write on their homework boards, and they can copy it down in their agendas.
What
Okay.
I'm gonna do is
Can
I'm
that be
gonna
tomorrow?
Yes, definitely.
I'm gonna take it and I'm gonna post the video on YouTube, so then that way we can track how many, first of all, people view it,
Right.
and then that way we can see if it's really helping. And if anybody has a comment or something underneath, they can ask a question. It's my YouTube account. I have nothing on there except an old grad school project, so I'm just gonna delete that video and then upload all of these on there, okay?
So we can just go.
It's a really good question. I haven't looked at it in a really long time, but I am on it tomorrow as soon as I get the video and I'll send it home. Okay?
So we just go to YouTube and then.
We're even gonna post just the YouTube link on the school website.
Oh, well,
So if you go to
then you can
fourth grade, it'll say Math Night Videos and you'll just click it and it'll open up right into YouTube.
And we'll move the division one
Over
over
there,
to
too.
that account too. But we can also post it up on homework and even make a slip of paper to us, staple in their planners with the links.
And we're always open to suggestions with anything, so if you
Yeah.
think of something that will be helpful to your child, we're happy to help and fix and adjust. Okay?
So we go from a mixed number to an improper fraction, but we also go from an improper fraction to a mixed number. And we do that by saying, if we have fourths as our whole, and we have 9 of that, that means we have 9 1/4ths. So we would write them out. 1, 2, 3, 4. Well, I know that 4 fourths is the same as a whole. So you would box it, and then underneath of it, you could write 1 whole to keep track of their thinking. And then you keep going, because you have 9 of them. We've only done 4. So we do another set of 4 fourths, which is another whole. And then we have 1/4. Well, 1 whole plus 1 whole is 2 wholes, and then we have 1/4. So 9 fourths is the same as 2 and 1/4. So again, if we have 8 thirds, that means we have 8 1/3s. Three thirds is the same as 1 whole, but you need to keep going.
You want it broken all the way down to 1/3, not 3 over 3.
Eventually, they're gonna get to a point where they might be able to skip count and then say 3/3 plus 3/3 plus another 2/3 would get me to 8/3. It's just decomposing it in a different way. So that's totally fine. This is the way we're gonna teach it in the most basic manner. But Mr. Kavanaugh is saying that the students might automatically recognize 3/3 is 1 whole, plus 3/3 is 2 wholes, and I know that that's 6/3, so I only need 2 more thirds to get my total of 8, meaning that I have 2 and 2/3. Eventually, they're thinking,
All the way down to 1, whatever it is.
This is
Doesn't
how we
matter.
start them, and then if they can make that connection,
They can
and
do
they
it like
can
that.
take that
So for
shortcut,
homework,
that's fine.
that's
Break it
fine.
down to either one. Okay.
So this whole thing is concepts.
Yes.
Concepts.
Well, we're gonna get into operations in a few minutes.
Alright.
But we're gonna start
start
with
there.
concepts.
Alright, so why don't you guys try 11/5?
Alright, 5.
And I can see that 5/5 is the same as 1 whole. But I'm not done.
Takes a long time, but they do need to know how to decompose these fractions.
Then another 5/5, which is another 1 whole. So our total is 2 and 1/5.
So I did see, we look ahead at their assessment when we're planning all of our lessons. So that's one of the first things that we do when we get the unit. We're supposed to long range plan and take a look at what they need to know. So looking at this, I do know that there may be something along the lines of select all answers that would equal 8/3. And they might have 2/3 plus 2/3 plus 2/3 plus 1/3. Then they might have 8 times 1/3 and all kinds of different options that they would have to select. We're going to get to multiplication eventually, and it's a lot easier than you think, but you would pick what is equal and what's not. Alright, so now we're at comparing and ordering like and unlike fractions. Like fractions are fractions that have the same denominator. Unlike are fractions that have different denominators. Those of us who are having trouble remembering what those parts are, your numerator is the top, the denominator is the bottom. Your denominator is your total number of parts, and the numerator is what you're discussing. So, back here. When you are comparing fractions with the same size parts, or the same denominator, you just look at the numerator. Very simple. I know that 4/6 is less than 5/6. I have one more 6. You can see that with fraction bars here. So 7/10 is greater than 3/10, correct? And 5/8 is greater than 3/8, and 2/3 is greater than 1/3. Very simple. Kids grasp this, super easy. As soon as we get to unlike fractions, we start thinking in a different way. We gotta throw that wrench in there. So, when we would compare unlike fractions in the past, the way I learned it is you would find an equivalent fraction to make it the same. Everybody in here probably learned it the exact same way. The Common Core way does not have you do that.
Okay.
It has you start to think about fractions in a different way. So, let's take a look at some of these fractions and try to sort them into the boxes using 1/2 kind of as our benchmark fraction. What do you know about 1/9? Would you say that that's more than 1/2 or less than 1/2? It's less than 1/2. It's only 1/9 away from 0. What's half of 9? 4.5. So that's way less, isn't it?
Oh.
If I look at 7/10, is that more than 1/2 or less than 1/2? More. What's half of 10? 5. So if 5/10 is equal to 1/2, I know 7/10 is greater than 1/2. So I could then put that in here. What about 1/3? Less than. Exactly. 1/3. What about 2/3? More than 1/2. What is half of 3? 1.5 or 1.5. So 1/3, while it's close to 1/2, it's not quite there. 2/5, same thing. Odd denominators make this complicated. Even denominators make this much easier. It's hard to think for kids, what's half of 5? What's half of 3? What's half of 7? That's a very hard concept for them to visualize. But if I said 3/4, they'd say, oh, 2 is half of 4, so this is definitely more than 1/2. 2/6, I know 3 is half of 6, so this is definitely less than 1/2. So they can use that to say 2/6 is less than 7/10. Wouldn't you agree? You can use knowing that 1/2 is right in the middle, and on a number line, these fractions would be on this side, and these fractions would be on this side. So we're using 1/2 kind of as a benchmark fraction. Any questions on that? Okay, just in case you're wondering, 2/5 would be here, 3/10 would be here, 3/5 would be here, and 2/2 is equal to 1 whole, and will be here as well.
So
Okay?
the Common Core concept is that they have to understand what each issue is called, beyond just addition, subtraction, multiplication. They have to understand what benchmarking fractions is.
Right, they have to reason about the fraction and say to themselves, I know what 1/2 is. Is this more or is this less? And using that, can I figure out, compared to another fraction, what it would be like? Probably. It just causes them to think more.
So what does Common Core do when you have a 7/8 and an 8/9?
Great question. Great question. Let me do this one first and then we'll get there, okay? 4/5 and 4/9. Say I had a number line. What do you know about 4/5? What's that really close to?
Close to 1.
It's close to 1. It's only 1/5 away. So I could sit here and write that this is close to 1 whole, right? This is what I know about this fraction. 4/9 is half of 9. It's 4.5. So this is close to 1/2. And I would know that this fraction is greater right away, just thinking about it in that sense. I could use a number line, I could partition it and say, I have fifths here, 1/5, 2/5, 3/5, and 4/5, and put it here. Then I could partition it into ninths and show the same thing. Gets a little confusing when you're doing it on one number line. But Mr. Kavanaugh brought up a great question. What if, let's put this one on the side, I said 5/6 compared to 7/8. Does anyone in here know which fraction is greater?
For the lower denominator is always gonna be. But you can figure out by denominator, because that's the percentage of it. So if you get 1 out of 8 wrong versus 1 out of 6, of course you got higher with 1 out of 8. But what happens if you threw two that were similar? With them basing it on halves and not an equal number, how are they?
If you think about this in terms of 1/6 is left and 1/8 is left, it gets it a little bit,
That's simpler.
right, it's simpler,
But
so you can think of it that way,
Very close,
like,
with different numbers,
like if I did
you
7/8 and 8/9.
Well, that'd still be the same, because it's based off one, but if you did, say, two different numbers, say, 8, 16, 18, I guess they'd break it down, 16 18ths,
Uh-huh.
and then, just trying to think of another one that would be real close, it comes out to a close percentage. How would you figure that out?
At this level, we're not gonna be asking them.
They're all gonna be basic concept, so,
I'm never gonna give them something like this and compare it to,
But couldn't you reduce 16, 18 to a?
yes.
you reduce
But
that.
you would only reduce fractions in the advanced class. We're not simplifying fractions in grade 4.
I'm just saying if I, like, I would
You would
hope
reduce
you're
it
not
before you
throwing-
compared it.
Yes, and I would hope
That's what I was gonna
Yes.
ask, why wouldn't
Coming
you
in.
just make that the most common denominator?
Right.
They don't do that in the 4th grade?
They do not simplify fractions in 4th grade.
Okay.
And
So-
with all of the things that we're doing in fractions,
Just drive
be
the kids
thankful.
nuts.
Be thankful.
Core's not, then, my thought was core was based on building, so this is the first step to the next.
Right.
It gets you there.
So they'll do that
But later.
eventually, but not in 4th grade.
And the
Like,
first thing they would do is simplify it and break it down back to basics. So if they ever were to come across a problem where it's 16 18ths and something
So
else,
eventually they will get to a common denominator.
For sure.
even in core.
eventually.
yes.
So the kids
Okay.
get this pretty good. It's us.
Yes, yes, and that's,
They're going to be
They don't
taught
know
the
any
way
better.
that you were taught in school, just not now,
Okay, so
later.
a later
That's what I
common
was gonna
denominator
ask.
will come into.
like, is this what has been going on in, not Common Core, but this type of fraction work been going on in 4th grade for a few years, or is it
No.
dropping down now because you're building up to, like, you know, if the bigger numbers are in 6th grade, they now want you starting building up to what 6th grade should be doing?
I've been teaching 4th grade for 6 years. We have not always taught fractions like this. Common Core math has completely changed the way we teach math. It's changed the curriculum, it's changed our approach, it's changed everything. But this way, I mean, if you're thinking about this, it gets them to really reason about what this is worth. They're really looking at it as 4/5, that's close to 1. They're thinking about it in terms of a value. They're not just saying, oh, let me find an equivalent, you know, and now I can compare them because I know this to this. So there are things with Common Core I really do genuinely believe in. There are some things where Mrs. Kimball and I look at each other and I'm like, oh my gosh, they're gonna kill us, the parents are gonna kill us, it's gonna be terrible. And then we get into it and then the kids really get it.
Well, they don't know any different, so.
Right,
So it's
exactly.
nice. I
They-
mean-
They never learned the other way.
I can't tell you, the first time I saw that division area model, I thought I had fainted and just, I was like, how are the kids ever gonna get this? But they do. They're resilient, and we need to be resilient with them. But anyway, back to this question. I always say to them, would you rather share a candy bar with 6 people or with 8 people? You'd rather share it with 6, you're gonna get more. If I keep cutting up that Snickers bar, then I'm getting smaller and smaller chunks. I don't wanna do that.
The bigger the denominator, the less.
Exactly, the greater the denominator, the smaller the pieces. So we do examine that and we will have conversations about this. So take a look at this one, 1/6 and 3/8. You know what, we're getting close on time, let's skip this one, okay?
Alright, so we are eventually going to get to doing the operations. We're gonna be adding and subtracting and then multiplying. So first up, we're gonna add with models, drawing pictures, and without models. So when you're doing mixed numbers, you add your mixed numbers first. 4 plus 4, 8. And then down here, they can shade their models if they want to. They have 3/8. And then they're gonna come in with 4 more. How many is that? 7/8.
And a lot of them would look at that and say, well, why do I have that extra one there? Sometimes it's just that they think about it. It's just we give them an extra one that they're really solving the problem and thinking. You don't want to give them the exact amount that they need every time. Then they just keep going and shading and they don't think about what they're doing.
Alright, so you guys do 6 and 6/10 and then 7 1/8. Add the whole numbers.
Can you leave your answer like that?
No.
So if you have 14/10 here, when we first teach them, we're going to have models. So they would say 6/10, 1, 2, 3, 4, 5, 6/10, plus 8/10, 1, 2, 3, 4, 5, 6, 7, 8. I know that 14/10 is really 1 whole and 4/10. So then I would say to myself, my final answer involves this number and this number. So you could rewrite it on the side, oops, and say 13 plus 1 and 4/10 gives you a total sum of 14 and 4/10. In the advanced class, after I teach them how to do simplest form, they will be required to put all of their answers in simplest form. When they add, when they subtract, when they multiply. Everything has to be in simplest form or it's wrong. It's tough. And what's hard about it is that the answer shouldn't be wrong because they have the same value. So that's where I would argue with the math in general because the answer is correct. It's just you're not putting it in the most simplest way.
Alright.
So for this here,
Skip that to times.
yeah, sure, let's see. Now we're gonna subtract. This does get a little bit dicey, but the models will make it better, and we're gonna show you a couple different ways to solve.
So, if your numerator at the top is greater than the numerator on your bottom fraction, you have no problem subtracting. You just subtract like you always have. 9 minus 4 is 5. 2 minus 1 is 1. Your denominator stays the same. That is only when your numerator on the top is greater than your numerator on the bottom. Now, if you have 3 and 2/4 minus 2 and 3/4, your numerator at the top is less than your numerator at the bottom. So that's where it gets tricky for kids. We can draw models, and we know that we would be taking away 2 wholes. So we start at the beginning, take away those 2 wholes. How many wholes do we get? Oh, not yet, don't do that yet. Now we would take away the 3/4. We've taken away the 2. Now we take away the 3/4. For this, we come to the end. We take the whole numbers from the beginning, and we take the fraction from the end. So if we're taking away 3/4, 1, 2, 3. We are left with 3/4.
So if you know how to draw the models, this will forever be easy. But you get bigger numbers and it gets harder to draw.
We take away the whole numbers from the front and the fractions from the back, because if we were taking away 3 here, then they would have to count them with 2 separate models, and it just gets confusing when they're looking at it like that. So we like to try to keep them as whole as possible.
Great point.
So there you would have your 3/4. And this is great if it's fourths and it's an easy model to draw. But if you're at sevenths, you might have a harder time. So 4 3/6 minus 1 and 5/6.
Notice that you have 1, 2, 3, 4 holes made out of 6 equal parts, and then 3/6. What would you take away first, the whole number or the fraction? Take away the whole number based on your picture. Oh wait, 1 hole.
Back it
What
up.
am I doing? I'm looking at 4. Take away 1 hole. And then I have to take away 5/6. Start at my fraction. 1/6, 2/6, 3/6, 4/6, 5/6. How many holes am I left with? 2 holes. And what's the fraction? 4/6. Is everyone following?
Yes.
It's just a more concrete way of looking at it. Gives them an actual model. We will get into regrouping next. It's a little easy. There are 2 different ways that we go about this.
So you can convert using the way that we learned, taking a little shortcut into making it an improper fraction, and then you'll be able to subtract easier.
But then you have to convert it back.
Right.
There's a lot of converting involved with this way. So 52 minus 30 would leave you with 22/8, and then you have to flip that back to a mixed number because 22/8 is technically quote-unquote improper. They don't like that name anymore because what's wrong with that fraction? There's nothing wrong with it, it's just a number. So they don't want to call it improper anymore.
So when the children are doing their homework, do they need to do the blocks or the,
We'll provide the blocks at first,
okay.
then we'll provide blocks where they have to shade them and then they cross them out. Then we're going to take the blocks away. And it's their choice. Either they can draw the blocks or they can start solving like this.
Oh,
This way is super complicated because you have to convert a bunch of different ways. Some of them prefer this. But the next way we're going to show you shows a way to actually regroup the fraction as if you were regrouping with subtraction.
So you will teach that way, the convert and the convert
Yes,
back?
we will. We will. Oops.
There we go. Nope, yes, stay there.
Hold on. We're skipping this example just for the sake of time.
Okay.
Okay, it would have been one just like this, where you would have converted it to an improper fraction, subtracted, and then converted. So, we'll get to this one.
So when we are regrouping for fractions, normally when we regroup a 10. Our number is a base 10 system. Well, when we are regrouping for fractions, your whole changes every time. So right now, our whole is out of fourths. So if we're regrouping and we're taking 1 whole from 12, 1 whole depends on your whole. 1 whole is, in this case, 4/4. So if we take 1 whole away from 12, we are left with 11 wholes. But we still have that 4/4. So we're combining that 4/4 with our fraction that's right here. So 4/4 plus 1/4 is 5/4.
So then you can do simple subtraction.
And then you don't have to convert at the end.
So you have your whole number and then you have your improper fraction on the side. And then you can easily subtract.
We're going to teach them both ways, and we basically leave it up to them, whatever they're most comfortable with. Common Core Math is all about teaching them different ways to solve problems and then letting them choose what's the best for them and their learning style.
So for the next one, I wanna do this one with you just because it is a little, we're doing the regrouping, but it's just newer. So in this case, if we take away a whole, our whole here is 6/6. Last time our whole was 4/4. So the big struggle is gonna be to get the kids out of the habit of taking away one and adding it to the next column. That's not what we're doing, it's not a 10. If we take one whole away from 8 holes, we are left with 7 holes. And that one whole turns into a fraction, 6/6. 6/6 is one whole.
And 7 plus 1 is 8.
But then we have 2/6. So we have 7 and 8, 6. And then you just bring over 4 and 5, 6. And then you can subtract.
Sorry, we're running a little behind. We're trying.
Hold up. This is gonna make our life at home easier.
Yes.
Plus, I'm not with them.
We won't be offended if anyone needs to leave. We want you to stay.
Miss A, for 3 and 3/6, would
I would
accept
love
3
for
and a
all
half.
of my students to sit there and say, hey, that's 3 1/2.
That's, is that where you're headed?
Yes.
Okay.
Um,
Anytime you can reduce a fraction, are you going to?
In the advanced class, it's required.
Okay.
So that's
In-
all, so that simplest form means breaking down even the fractions.
Yes.
Like
That's
before,
how
there was
it's
one that
done.
was 2 6/8 or whatever.
You would
or
break it
4/6.
down.
Okay.
This would have to be the answer, right here.
And they're gonna know
Okay.
that, right?
Yes, we will teach that in the very beginning. For grade 4 students that are not in the advanced class, they do not have to do this, but I'm going to encourage this always for 1/2. Always.
But even if it was not
2
like
eighths.
if it was 4/6,
Yep.
they're gonna find what's common.
For the advanced class, every time.
Okay.
It will become habit, I promise. It really will.
Did you get it? Like me.
Okay, that's me, right? Okay, so topic 7 is estimating sums and differences with unlike fractions.
And this is where that benchmark understanding of a half, greater than half, less than half, really comes in handy.
So we say to them, when you add 1/2 plus 1/2, what's the sum? You get 1 whole, right? So you should think about your fractions and say, well, what would 2/6 plus 4/10 be? Would that be more than 1 or less than 1? And that's as basic as we're going this year. That's all we're gonna have to do. You're not gonna have to say, oh, well, it's going to be about, 9/10. No. You're just gonna tell me if it's less than 1 or more than 1.
So you got a 50-50 shot, huh?
You have 50-50 shot, exactly, that's a good way of looking at it. And what we like to do is, to solve that problem, you would say, I know 2/6, that's less than 1/2, isn't it? What about 4/10? That's also less than 1/2, correct? So if I add 2 fractions that are less than 1/2 together, am I going to get 1 whole? No, I'll be under. So my answer here would be less than 1 whole.
Now, do they illustrate that too?
There could be a time where they would illustrate it. If they draw
And see
it,
how many pieces was more?
they couldn't draw it on one picture because you would have it partitioned into sixths and then
They need
tenths,
2 different illustrations.
which they could do.
But they need to make sure that the whole picture is the same size.
Okay.
And that's where it gets dicey with it. Some kids will wanna draw, if they have their circle like this, their other one might only be that big.
Oh,
And then
okay.
you're,
Okay.
And I shouldn't be drawing circles, we encourage them to draw squares. So if I had a hole here and a hole here, and I'm going with sixths, I see that 2/6 is definitely less than 1/2, don't I? And if I do the same thing here, with tenths, I also see that 4/10 is less than that 1/2. And if I know that this half plus this half is 1 whole, I'm definitely not gonna get to a whole, am I? So we will have area models, we will have number lines, we will be thinking in terms of 1/2. There were some examples in previous years where we would say 4/6 plus 2/5, and one is greater than a half and one is less than a half. We're gonna try to stay away from those this year to make it more basic and more easier for them to understand. That's what we really wanna go for. So if I looked here at 3/6 and 7/10, what do you know about 3/6 right away? It's equal to 1/2, right? And then what do I know about 7/10? Compared to 1/2, is it more than or less? It's more. So my answer, is it gonna be more than 1 or less than 1? It's gonna be more than 1. And this would count as showing their mathematical thinking. Just simply writing greater than 1/2. That shows their thinking right there. That's all they'd be required to do. Down here, same thing, 5/8, greater than 1/2, 7/12, greater than 1/2. When I have two pieces that are greater than 1/2, I'm definitely going to have more than 1 whole. Is everybody with me so far? Ooh, whoa. All right, multiplying whole numbers by fractions, unit fractions with models and without models. Almost there. Is this me or you? It's me. Okay. So when I have 7 times 1/5, that's literally me saying 7 groups of 1/5, which is a very important concept. That also means 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5. It's my repeated addition sentence. 7 times 1/5, whenever you multiply a whole number by a fraction, you just multiply the whole number by the numerator. And you wind up with 7/5, and you would have to convert it. It's relatively simple. A lot of the kids really grasp this very quickly. The thing that's hard is having the models, and that's where we start with, because you want to start with that really concrete representation of what it really means. This is more abstract, but it's also very procedural. The kids can grasp, oh, I multiplied a 7 times a 1. If I gave them 8 times 2/3, they would sit here and say, okay, well 8 times 2 is 16, and then I have 16/3, and then they would convert it. They're going to grasp that very quickly. Knowing what it means is important. A unit fraction is when the numerator is 1. That's just another term that we're going to be using. So if I move on to the next page, again, 3 times 3/4 is 3 groups of 3/4. 3/4 plus 3/4 plus 3/4, which again is 3 times 3 is 9.
So you don't put that 1 underneath anymore.
That's what I'm used
Do
to.
they do that? No, perfect. And then you would have to convert this using any of the strategies that we've taught you. That's why they go with the concepts first, because then I'm left with this answer, and what do I do with it? What does that numerator mean?
Did you learn that strategy tonight, or is that previously in the division?
9/4.
To convert that to 2 and 1? Like, I
Well,
just know it.
I just taught that in the advanced class as a division problem. So the students in the advanced class just solves problems like 2 divided by 3, and each person will get 2/3.
Is that like the one that came home and said draw a picture of 6 divided by 8? And I was like, I
Yes.
had no idea what this was.
Yes.
But will the other class be getting that too?
No. No. Next year, yes. Not right now.
Right now, in the regular math class, we would teach them to
Just
either,
this year.
they could write out, they would have 9 1/4.
Okay.
So they could do 1/4, I'm at 4/4 now, I know that that would be 1 whole. And then you keep going until you would get 2 wholes with 1/4 left over.
And then in the advanced class, we did 9 divided by 4,
Right.
I know I can have two groups, meaning I would take 8 away, leaving me with 1 left. So I have 2 holes with 1 out of 4. There's my answer.
And these would all be basic division facts with remainders. So the hope is eventually they would be able to
Get
see,
there.
oh, well, I know that it can go into that 2 times. Or 2 times 4 equals 8, and that's close to 9, it's just 1 left over.
So they may not be solving it this way, but they should look at 9/4 and think 4, 8.
And they would have to do the simplification method and get to the 2 1/4.
Yes,
You can't
this would,
stop
you
at
can't
the
leave your answer
improper
as an improper fraction.
Okay.
It's just not allowed. So 7 times 1/3 would give me what?
7/3.
7/3. And what would that be as a mixed number? Because I can't leave it like that.
2/3.
2 and 1/3, good. And you probably thought of that as 3/6, then 1 left over. Over here, 8 times 2/5, that gives me 16/5. 5, 10, 15, that's 3 holes, 1 left over. And that's definitely a quick way. Eventually, the kids are gonna stop listing out their unit fractions. They're going to skip count. You want them to get to that point. I don't want them to be sitting there listing it out forever. The goal is to start there and gradually wean them off. I would hope that by March we'll be there, for sure. All right, so now whole numbers by mixed numbers, this is new. We've never taught this in 4th grade before, but it's just one more step. So if I was gonna do 8 times 2 and 3/5, all I would do is break it into 2 separate problems like partial products. I would do 8 times 2, then 8 times 3/5. I know how to do both of these things, don't I? 8 times 2 is 16. 8 times 3/5 would be 24/5. Then it converts to 4 and 4/5. And I simply just take those 2 partial products and I add them together. Break it down, make it simple. 5 times 6 and 2/8. Multiply the whole numbers first. 5 times 6 is 30. Oh, my kid's in here, come on. Multiply the whole number by the fraction. I already did 6, so now I do 5 times 2/8. How many 8s am I left? Do I have now? 10 8s. That converts to 1 and 2/8. For the advanced friends, they here would have to say 1 and 1/4. Okay? And then you take your partial products and add them together. And that's your final answer.
Oh, you can leave, okay, as long as it's not an improper.
As long as it's not an improper fraction, you're totally fine. So before, when Mrs. Kimball was adding some of her problems, she wound up with something like 13 and 14/10. You can't leave it like that.
Okay.
You would have to take this number and convert that to 1 and 4/10, where you would then add those 2 together.
Okay.
But this, totally fine. Advanced class, it would have to be 31 and 1/4. And you just learned Unit 4 of 4th grade math. So, who's ready for a test?
Not me.
Kidding. So, math, mental abuse